Hi scientists, in this video we're going to be looking at some neutralisation and other acid-base reactions. So we're just going to get into this one quite quickly. The first acid-base reaction we want to look at, you want to define this as a neutralisation reaction, okay? So when an acid reacts with a base to form a salt and water, we get this neutralisation reaction. So basically we're cancelling, great pun there, we're cancelling out the acidity of the acid, the basicity of the base, and we're forming something that is no longer acidic or basic, hence the neutralisation. Okay. The really simple word formula is acid plus base goes to salt plus water. An example of this is hydrochloric acid. So this is one of our most common acids with sodium hydroxide, again a common base, and you're going to get sodium chloride, table salt, and water, okay? And we have our states, so all aqueous, and water is considered a liquid, okay? Aqueous is an ionic compound that will dissolve in solution, whereas water is your covalent solvent, so that's why you have a liquid there instead, okay? So that's the first type of reaction we'll look at. We're going to look at some other common reactions involving acids, and we'll look at 4 of those. The first one is an acid plus a metal. Now you've all probably seen this before when we put some magnesium or zinc metal in some hydrochloric acid and you see the fizzing and bubbling, okay? Now you're going to get a metal salt plus hydrogen gas, and we all know that hydrogen gas is flammable. That's when you do the pop test, so you put the lip match over the mouth of the test tube and then that pop sound indicates hydrogen gas. You wouldn't want too much hydrogen gas, otherwise it's going to explode in your face, and that's not what you want. Now this doesn't occur with some less active metals like copper. Mercury is a liquid, it's not going to work very well. You're not going to really have access to that anyway, because that's quite toxic. And silver as well, too expensive for us, let's be honest. So an example for an acid plus metal equation, I'm going to stick with H2SO4. You guys know what that one is, right? You guessed it, it's sulfuric acid. So sulfuric acid plus zinc metal is going to go to zinc sulfate, which is your metal salt. So you're going to see the zinc and the sulfate ions connect together, and you're going to get hydrogen gas, which is H2, and that's a balanced equation. Hydrogen is gas, so you have a G for gas there. At the bottom, we've got an ionic equation, okay? Now the ionic equation is removing the spectator ions, okay? Now the sulfate ions are going to be present in the solution, but they're going to be spectators, so they're not participating in the reaction. So this is the ionic equation down the bottom, okay? 2 hydrogen ions plus zinc metal will go to zinc ions and hydrogen gas, okay? So it's cancelling out the spectators. We've just got a visual representation here. This is actually zinc with hydrochloric acid, but it's the same concept. You're going to get some fizzing and you're going to get a salt produced. So that metal is going to dissolve and you're going to end up with your salt. The second reaction is an acid metal carbonate reaction. So acid plus carbonate will go to a salt plus water and carbon dioxide. So the previous one was hydrogen. Instead, when you have a carbonate, you get water and carbon dioxide. So a similar example using sulfuric acid again. This time we've got a metal, so calcium, combined with a carbonate. So carbonate is always CO3. Okay? Calcium carbonate is limestone, which is used in buildings. You're going to get calcium sulfate, which is your metal salt. So you can see here that basically with the acid, the sulfate is always going to come off and attach to the metal, and that's going to make the salt. You're going to get CO2 plus H2O, so carbon dioxide gas and water. With your ionic equation, again, the acid is only H plus ions, 2 of them because it's H2SO4, and you're going to get calcium carbonate goes to calcium ions, carbon dioxide, and water. And calcium carbonate is a powder, so limestone, like I said, or chalk, and you get that fizzing. The third one is an acid plus a metal oxide will go to a metal salt and water. So acid plus oxide goes to salt plus water. Again, sulfuric acid we'll have a look at. you're going to go to magnesium. This one's magnesium oxide. So metal oxide is the addition of oxygen to a metal, and you're going to get magnesium sulfate plus water. The ionic equation, again, 2H plus MgO goes to Mg2 plus, so your metal ions and your water. This is our metal oxide, so magnesium oxide, and then your metal salt in a crystallized form. So this is obviously not being dissolved in the water. If you get rid of the water, then you get something that looks quite crystallized like this, because it's an ionic compound as opposed to the metal oxide. The last one we're going to look at for this lesson is an acid plus a metal hydroxide. Okay, now this one here, sodium hydroxide is, a hydroxide. You're going to get a salt plus water. So essentially, this is the same as a neutralisation reaction. Okay, so acid plus hydroxide will go to salt plus water. Okay, and this is the example again with your sulfuric acid. The ionic equation is a little bit different here because the spectator ions are both of these, because they'll combine in solution. Okay guys, so thanks for looking at this video to do with a few of the different neutralization and acid equations. A task I'm going to set to you, or a challenge I'm going to set to you, is can you replicate the 4 types of acid reactions using a different acid? Okay, so I went through sulfuric acid, so select one of these two, either hydrochloric acid or nitric acid, and recreate the equations, both the full chemical equation and the ionic equation, including states for the 4 different types of reactions. Record those in your book, and I'll see you next lesson.